happened to be employee number 5 when Yahoo started. And when he came out, he was the executive vice president over there. After which he had his own company, which he eventually sold off to AOL, as you know is the case normally. And then he was working for a non-profit organization before he joined hands with our co-founder and CTO, Mr. Amol Kekre. Amol himself was also with Yahoo for a long time after he graduated from IITB. He is the chief architect for online streaming quotes that we see on Yahoo Finance. And after that, he was the director of engineering for their advertising group, followed by the director of engineering for the Hadoop 2.0 group in Yahoo. So nearly, I think 60 or 65% of the Hadoop developers working on 2.0 were reporting into him at that point in time. So that's where he knew what Yarn is, which was not yet released. And since he has worked on this Yahoo Finance applications, he exactly knew what are the requirements of any streaming application. So combined it and started off with what we today call as Apex in the open source, and we call it as Data Torrent RTS as a part of the enterprise edition. Right? So when we started, there were two parts to this project, and we'll look at that. We'll get into more details. But there was a library of operators and an enterprise product, which was the platform. So the platform we developed till I think July this year. And that's when we actually open sourced it. So it's quite stable because it has gone through nearly 3 years of thorough testing, even customers using it in production. So that helps. And thankfully, I really want to thank some of our customers because you know how customers use your product, right? It's not possible to create the environment when they deploy it. And that environment you just can't create in a dev setup. So we literally got so many different scenarios in which we had not imagined someone would actually use the product. So it helped us locate a lot of bugs. Plus, it also helped us optimize quite a few things. So that's what has got us to where we are today. And towards the end of this presentation, I'll show you one slide which was presented today morning our time in a meetup which happened in Chicago. So I have not actually received the official slides, so I couldn't show you all the details over there. But I have some data in terms of numbers, which I'm pretty sure will excite you guys. Okay? So, okay, let's start. So this is the logo, of course, for Apex, Project Apex as we call it. My name is Milind Barve. I head the data torrent team over here in Pune. Our office is located in Bopodi in Pune IT Park. And feel free to drop in anytime if you have any questions, you want to know anything. All of us I'll be more than happy to help you out on that. So as I said, the project development started in 2012 at Data Torrent in Santa Clara. We open sourced it in July of this year. And the incubation stage started off in August 2015. So it's been around 3 months in incubation. We recently, in fact, we're on a border of doing our first release right now for Apex. So the current project status, if you ask, it's in the incubation state. You'll find all this information on the Apache Software Foundation website in terms of what it is, the description, all possible news, all possible product info. This is the mentor list for this particular project. So you have people from, you'll see various companies related to Hadoop. So you have Ted Dunning, I guess most of you would be knowing this name at least. Alan Gates from Hortonworks, Taylor Goetz from Hortonworks as well. Justin McLean, Chris Noruth, and Hitesh Shah from Hortonworks. So these are the guys who have been mentoring us from the perspective of how to be a part of Apache, what happens in an incubation stage, how do you release and all that stuff. So these have been sort of our guides as such. Apart from that, this is a list of companies from where we have committers on board. So we have committers from Cisco, Capital One, GE, Apple, Silver Springs, DirecTV, Barclays, and of course Data Torrent. So there are a total of more than nearly 50 committers already, and this list is growing. Now, just to give you a rough estimate of what this, a rough idea of what this 50 number means, I don't want to name any product, but one product which has been around for a long time has just 2 committers on their list so far. The other product, which is pretty new, has around 11, of which 10 are from the company from where it originated. So considering that and considering this list of companies from where our committers come in, 50 is pretty big a number. And we surely want more and more people to come and be committers. And we really would like all of you to also start contributing. Okay, so what are we going to serve you today? So how do batch and streaming, the two worlds, collide with each other? I mean, so far we have seen that a lot of people, when they talk about data analysis, they talk about batch processing, right? But especially over the past 2-3 years, and with the proliferation of handheld devices, I mean, from a consumer perspective, you know how data has started exploding, and there's no way it's going to reduce. In fact, if anything, it's going to start getting more and more with every passing day. So what that means is, since you have more data, you also need to make sure you analyze that data and get value out of it as soon as possible. Because with time, the value of data decreases exponentially. So from a customer perspective, if you think about it, your customers are wanting two things. One is they don't want to lose out on the value of data. And secondly, they're also afraid that if they don't do that, their competitor will do it and take away their business. So from both these perspectives, everyone wants to basically start processing their data as soon as they can, derive value out of it. And the second part is it doesn't stay at deriving value out of the data. The next part is how do you make decisions based on it, and how do you convert those decisions into actions. So getting the value is just one part of it out of analysis, but the more important part is once you have that, how do you convert it into some actions which are going to earn revenue or maybe save costs for your company, right? That's the more important thing. And you'll find that this platform enables you to do all this stuff. So then we'll get into some nerdy features of the Apex engine itself. We'll surely answer some questions if you still have. And that would be followed by the next session wherein you will be able to sort of develop your first application on top of Apex. Okay. So how many of you know the Lambda architecture over here? Cool, there are a couple of folks, great. So from a Lambda architecture perspective, there are some things that I surely like to talk. So you have data coming in. Now, data that is coming in, everyone wants to run queries on top of that, generate reports on top of that. So that's how they are consuming data. The challenge is there's so much of data that how do you even get those queries answered as quickly as possible? So in the Lambda architecture, you'll find that there are 3 different layers that you see. One is a batch layer, which is your master data set. And what it does is basically there's pre-computing of data that happens over here. And this pre-computed data is made available to the serving layer. In the serving layer, what happens is the queries directly are serviced by this particular layer. And this is the layer on which you can run different types of queries. So the same data you could basically look at from different angles. Now, what happens is this is fine for your historical data. But while you are doing all this, there's also the other aspect that comes into the picture, that what to do with the data that is coming in while you are doing all this processing, right? So that again is going to be a huge amount of data. So that's where the third layer, which is the speed layer, comes into the picture. The speed layer is getting the data which is coming in while you are actually processing it in the batch and the serving layer. And that's the streaming concept of it. And what happens is when you are actually running a query and you are expecting that the results should be consisting of data that is up to date, the data from these 2 different layers is combined together. So you will get results from the speed layer. You will also get results from the serving layer, and both of them are combined to actually present you with the query results. So that's how actually you get up-to-date query output based on whatever you had been querying. So that's a typical Lambda architecture. If you look at how we do it, from a data or from an Apex perspective, your new data is coming in. It's going into a single layer. It consists of an incremental layer wherein your data coming in is getting incrementally added to the data set. You have an aggregation layer wherein it is getting aggregated. And then you have different views on this aggregated data on which you are querying. So that's what we call an aggregate query. So you can basically get different views on the data that has been aggregated, and how you want to aggregate can be something that you define, because there will be different ways in which every customer might want to do that. Right? At the same time, since we are getting this incremental data and keeping it with us, we are also enabling you to run incremental queries on this incremental view. And these queries are also rolling queries. So it could be like some query for the data which has come to you in the last 5 minutes. Now with time, as you move forward, that 5 minutes stays the same, but the 5-minute interval keeps on changing with you, right? So you might want to run queries continuously for the past 5 minutes of data. So that's also something you could do using Apex. Right? So this is how you could say it's similar as well as different in a way to the Lambda architecture. as a platform, so just to give you a brief idea as an analogy, if you consider Hadoop to be an operating system, right, similar to an operating system, then the platform that Apex has, or Apex itself as such, can be considered similar to a compiler. And on top of Apex, we have something called operators. We'll just talk about it a little bit more in some time. And those operators enable you to build your business logic. So those operators and the business logic you build out of it can be considered similar to, say, a C program that you would be writing. So that's just an analogy from the perspective of how it works or how it is positioned. Now, this is software-only solution. Again, there's no hardware involved. It can coexist on your Hadoop cluster with other solutions. Again, there's a figure wherein I can explain that to you a bit more. But that's an analogy that you could keep in mind, which will make it easier for you to understand it. So looking at the infrastructure perspective, we can run on a Hadoop cluster, which could be either on a physical or virtual machines, or it could even be on the cloud. This is a platform which actually is a Yarn native application. So it runs on top of Hadoop 2.0. That's a prerequisite, by the way. So we can't run on Hadoop 1.0. It needs Yarn, and so Hadoop 2.0 is a prerequisite. Again, which Hadoop distro, if you ask me, as mentioned over here, Cloudera, Hortonworks, Pivotal, MapR, we run with all of them. Along with that, we have actually customers using it using EMR. We also run on Azure. We also run on Google Analytics. So, you name a distro of Hadoop, and we actually run on that. So from our perspective, those things are transparent to us. What the platform does is it makes you Hadoop services available to your application. That's the basic of the platform. So if you look at it, you have the streaming runtime, which is the Apex platform. On top of that, you see Malhar, which is a library of open sourced operators. If you ask me what an operator is, any logical operation that you could perform writing an independent piece of software is an operator. There's no restriction on what can or cannot be an operator. It might be as simple as integer addition, or it could be as complicated as a complete algorithm all by itself. Yeah?
So this streaming runtime, is it MapReduce or is it your custom?
No, this is not MapReduce. This is at a very high level similar to MapReduce, but it's not MapReduce. In fact, this is replacing MapReduce in a lot of places. So we have all these operators. The library name is Malhar, which is also open sourced. You can take a look at it on GitHub. These operators are grouped in various categories. So you will find mathematical operators, statistical operators, algorithmic operators, ones which deal with log files, ones which deal with input-output, all sorts of data stores, basically. So you can find a lot of such operators. Taken together, there are more than 400 operators that exist today. On top of these operators, we expect folks to start using these and build their own applications. These operators are used to actually build your business logic. So just as an example, if I could take maybe you're getting streaming data in the form of stock quotes, right? And you want to follow a particular script. And you want to see that once the average price crosses a certain limit, you want to perform some transaction. It could be either a buy or a sell, right? So what's going to happen is for that first thing you are going to need is how do you compute the average of incoming data, right? So as we all know, computing average involves 3 steps. One is you actually add the data. You add be it float, real, whatever type of data you have. You count it. And the third thing is you divide the sum by the count. And that's how you get the average. So there are operators for each of these logical steps. So you can pick up a summation operator from our library. You could pick up a counter operator from the library. You feed the incoming data stream in parallel to both these as input. Now, each of these operators will actually perform whatever operation that they are supposed to. So none of the operator interprets any data. So the summation operator just will keep on adding whatever it is getting, and it will emit the result. When it emits the result, you'll get to know in one of the slides later at the end of the window. Just you could remember that right now. Similarly, the counter will just keep on counting the tuples it is getting and emit the count. Both these outputs go as input to the third operator, which is a division operator. So division knows that it has to divide one input by the other and give out the result, and that's what it will do. Taken together, you have now calculated the average, right? Now, potentially, you could give the average to another operator, which is a comparator, and you could have a threshold inside it, which is hard-coded, or it might be coming from some other system. And once you compare the average with this threshold, depending upon whether it's less than or greater than, you could then send that to the next operator, which could actually trigger a buy or sell transaction for you. So all this is happening in real time. instead of stocks, if it is say temperature control or sensor data, right? Then instead of sending it to some operator which is going to trigger a transaction for you, you might be sending it to an alerting operator which might raise alerts, SNMP or SMTP or whatever it is. So all these operators are already available. What the user has to do is pick up these operators, connect their outputs to and inputs together, and complete the business logic. And that's how simple it is actually. And you'll see that when Bhupesh shows you how to develop the application. Okay, yeah.
So does Malhar expose some API to write custom operators?
Yeah, so you can write your own operators, and that's what I was just going to say, that while I'm saying all these nice things, it is not that simple because from a business perspective, every business has their own business secrets which are a part of their business logic, and no one is going to put that in the open source community, right? So typically the businesses have one or two of their own operators which also come into the picture, and you would have to write your own business logic as operators and then combine it with all these existing things to complete your business app. So, yeah.
Mostly it's gonna be based on a window, right? Or
Yeah.
So what is like? Do you also provide tolerance levels like this sort of, because your messages can come out of order and maybe some of the average calculation may actually be skewed because of that. Do you keep track of it or just
See, that pretty much depends upon your business logic, right? We provide you a way to do that. Now, how you want to do that? Because it's possible that when you're getting messages, you might get some messages which are sort of laggards, right? So you might still collect them, and you might say that you want to take that into account for the past 2 hours. Anything that comes after that, you want to discard, right? So for that, you will have to hold the data in memory when say you are performing whatever operation is, and then after that 2-hour window, you will have to also pick up that data and then compute whatever you want to. So it mostly depends upon what sort of computation you want to do. See, from an Apex perspective, we are a platform which enables you to process data in motion. Okay, so it could be streaming data or it could be from data at rest. As long as we can read the data and get it into the stream or get it in in your business logic, we'll process it. So this is what you are asking, right? It is something very much tied to your business logic in terms of how you want to really do and what you want to do with that data. Because many times it happens that that data that you are getting in this manner, many times it's also duplicates, right? So you might actually not want to take it once you have taken the first tuple. So it's very much dependent upon what your use case is. Any other? Yeah.
Do you support data flow graphs? Meaning that there could be 2 different data sources and then some filter on top of that in a join.
Yeah, sure. So if you look at Malhar, we have nearly 70 plus operators, as we call them, just for data stores. So input as well as output. So you could have, for example, data coming in from Kafka, and at the same time you might also be reading from HDFS. Combine that together by performing whatever computations you have to, and then that goes as a single stream ahead.
Now if you put this with your another example of that hourly stock code or something,
Mm-hmm.
that it may have one of the data sources is faster,
Right.
and one of the data sources is faster and its data gets outdated sooner.
Right.
Then you need some kind of shedding of load.
Yeah.
So does the framework support that?
It supports in the sense you will surely have to store this data somewhere, right?
No,
So you
I
could
want to discard.
Which data you want to discard? So you have 2 data sources. One is coming in real time as a stream. The other is coming maybe also as a stream, but it is lagging behind the first stream, right?
Yes, and it is at some point it lagged so much that beyond our capacity to process.
Right. So you want to discard the data coming in the second stream, right?
Yeah.
So yeah, that's perfectly possible. I mean, that's the logic that you will just have to specify in the operator that you write.
Is there anything in the framework does for me, will do for me that?
Framework is like an infrastructure.
Yeah.
See, this is the business logic that you have, right? Framework will enable you to make sure that you are able to do it.
Okay.
Think about the framework as something which exposes you to all the Hadoop services, right? So today, if you look at an application developer, what they are supposed to do is they are supposed to develop business apps, right? But while they do that, because of their domain expertise, what they also have to take into account is the fact that how is my application going to run? What happens if, say, my node goes down, right? How do I recover from that? So all these things have to be taken care of by the app developer, and they're good at it. But they have enough other domain-specific problems which they could add a lot more value on, right? So if someone else could take care of these problems for them, they could concentrate on the business logic. And that someone else is the platform. So this platform will give you all this functionality. For example, it gives you fault tolerance out of the box. It gives you dynamic scalability out of the box. All these infrastructure-related services using Hadoop, of course, are given to you by the platform. And you don't have to worry about how to do all this. You just concentrate on solving your business problem. Okay? Anything else? Any other question? Cool. So yeah, so the top portion, it's available in the enterprise edition. So that is available from Data Torrent, of course. This is the categorization of all the Malhar operators. So you will see there are input-output operators for file systems, RDBMS, NoSQL, messaging, notification, in-memory databases, social media, protocols. So this is again a high-level classification. So for example, in file systems, again, you will find that you can read from local file system, from HDFS, a number of different file systems. Similarly, with messaging, you could actually read from Kafka or RabbitMQ, a number of other messaging systems that you could use. And there are compute operators, so you'll find pattern matching operators, statistical and mathematical operators. There are some machine learning algorithms. We are still developing more on that front. There are parsers, UI and charting operators, stream manipulators, querying and scripting operators, and also related to social media. So I surely would like to tell you that go and take a look at Malhar. You will see a lot of these operators. This is at a very high level, and I'm pretty sure you'll appreciate all those operators because that would make your life a lot simple. So this is how their application would look like. This is, of course, a directed acyclic graph, or a DAG as we call it. The two main components over here are operators and streams. So this is an operator. What an operator does is it takes input in the form of tuples, and it emits some output also in the form of tuples by processing the input tuples. Operators are connected to each other through streams. So streams actually carry the data from one operator to the other. And an operator can have multiple inputs and can have multiple outputs again. Tuples is the basic unit of data that we use. And the way it works is you are getting these tuples. Every tuple gets processed right away. So that's the difference with respect to some other streaming solutions, especially that people think about. The way we work is every tuple gets processed right away whenever it lands in the system. In some solutions, they do microbatching, wherein what happens is, say, just for the sake of an example, your microbatch is, say, consisting of 10 tuples. So in that case, what happens is your first tuple that comes in has to wait till the other 9 come in. It sits together over there, and then the entire set of 10 is sent forward for processing, right? So the first tuple is affected by a latency because of the next 9 tuples which are going to come in. In our case, how we do it is we don't wait for any tuples. The moment any tuple comes in, it's sent ahead for processing. At the same time, we have a concept of window boundaries, which we keep on marking. So we exactly know which tuples belong to which boundaries. And so we get an ACK for that entire window. So while the tuples we still create microbatches in a way, but none of the tuples actually sits there waiting for other tuples. And that's how we achieve the optimal performance. Okay, any particular questions on this?
But then at some point of time it will wait, right? Because your aggregates, it will depend on window.
Right, so if you're aggregating something, right, then naturally you will keep on adding the results. And you want it to wait, right? But from a processing perspective, it's not going to wait. And windows would actually cascade from your upstream to the downstream.
So does it put any sort of limitation in terms of what sort of? Does it put any limitation in terms of what sort of logical operators you can use? For example, negation operation, because your window is not fully committed. So you cannot derive few facts because you're still open in terms of window because you're processing one event at a time.
Not really, because the windows propagate as individual entities, right? Now, how we do a commit, basically the commit also propagates from your upstream to the downstream operator. And unless and until the entire set of operators or an entire DAG has committed it, it won't be written down to the checkpoint. So you'll still have it in memory. we have a structure in between, between these two operators, which we call a buffer server. So that is something which holds your intermediate data as well, transient data, I could call it. And just in case, I mean, I'll even take it that there's too much of data coming in. In that case, the buffer server will spool to the disk. And
actually, my question is a bit different. Actually, for example, if I have negation saying that I'm not observed this sort of pattern coming in, so
okay.
it's sort of a not operator. But then not operator has to be there. For that not operator to be useful, I need to know the full window. Otherwise, because any event can come in at any point of time, and my logic will be invalid after that. So
I didn't. Okay, so
probably we can take it offline.
Yeah. No, I didn't get what you mean by. And
the question he has is his logic depends on the entire data for that purpose. Yeah. You have to still hold that data and take that in that case.
Right, right. So we can very well do that. Say, for example, if you take an example of aggregation, right? So you want to maintain aggregates for, say, last 1 day, right? And you want to run queries on that. Now, you can't have a tuple going directly to that, and you keep on adding that tuple every time. What you typically would do is you aggregate for each window, and those aggregates then you send to the actual aggregator operator, right? So you will have, in this case, 3 different operators. One which is reading the data, second which is aggregating for a window, and a third which is actually maintaining all the aggregates. So that's how you would handle it, because the second operator now will always do it on your window basis. Okay. Does that answer your question?
Probably I'll have to.
Sure, sure. Any other questions? Yeah.
So, do you maintain copies of operators?
Yeah, so you could have, you can have multiple instances of the same operator running at the same time.
My question was mostly related to how do you handle, say, data loss in case, say, tuple arrives and the node goes down.
Yeah.
And if in case you have don't have those in multiple copies, then how do you handle it? And if you have multiple copies, then how do you handle dedupe?
Right. So couple of things over there. What we do over here is we do checkpointing onto HDFS periodically. Okay. Now that is again configurable, but that's how we enable that no data is lost. We prevent any sort of data loss. So what happens is if a node on which some operator is running, say it crashes, right? The master for the application knows that the node crashed. It will communicate with Yarn and get some resources within your Hadoop cluster where another instance will be brought up of the same operator. Now, right. So the data is coming in, and that data which has been coming in, rather in fact even before that, the operator which had processed some data after a window boundary, because till a window boundary it has emitted. After that it had processed some data and then it crashed. So what happens is that data, right, which has been committed, which has been processed after a window boundary, and rather let me just go a step further. What happens is we go back to the previous checkpoint that we have. Okay, we start processing all the data from our previous checkpoint, and all this data that has been coming in, that is held in something called as a buffer server, right? So we have all this data from the checkpoint onwards till the next checkpoint is taken. All this data is cached in what we call a buffer server, which is at the container boundary. So the moment this new operator comes up, it will start reading all that data from the upstream buffer server, and that's how it gets all that data again. So you could think of it as an in-memory data structure, which is.
But does it reside on a single process, or it is a different process? I mean,
so
let's say we discuss about the operator running on a node.
Right. So
if we have a buffer server on the same node, I guess that might not be very useful. So that's why.
Right. So what happens is the operators are running inside containers, right? And containers are running on nodes. So container boundaries is where the buffer server exists, and buffer server will keep on spooling the data onto the disk on HDFS. That's where we take the checkpoints. So since it's on HDFS, we can come up from that checkpoint straight away, because.
So that buffer server is part of your Hadoop cluster.
Buffer server is a part of Apex platform.
I mean, is it part of the?
Yeah, it is also running on the Hadoop cluster. It's an internal data structure, you could think of it. Yeah. It's running on the container boundary. It's used for, operators across containers to exchange data. Rather, downstream operators read data from the buffer server.
So basically, one operator is launched with one container.
Right, right. Um,
What service extra service which is running, or it's again a yarn container?
you could think of it as an internal data structure that we use.
I mean,
So,
it must be in a JVM or somewhere, right?
right, it is. It's more associated with a container or operators running inside the container.
If the
Because what happens is if there are more than one operators running in the container, then there is a different mechanism they use to exchange data. But if you want to exchange data across container boundaries, that's when you use this buffer server. Okay, yeah. So we could take it offline during the break as well, in the interest of, yeah, sure. So we are going to have dedicated sessions for each one of these topics as we move forward, okay? So this is the component overview. You have a node which runs the Apex-Master. You have Hadoop. You have other nodes which are running, operators inside containers, and each of the node does have a STRAM child, as we call it, which is communicating with the master, and that's how the master knows exactly what's happening in that particular node. So it's like a proxy for the master running on each of those nodes, right? And this data torrent RTS management server, REST API, that is available as a part of your community edition. So if you download a community edition, you would still get that as well. That's the addition that data torrent provides on top of Apex. Okay, yeah, we'll just quickly go through the. Okay, sure. So if you look at this, this is a Hadoop cluster that you have. You have MapReduce jobs running on it, and at the same time, the operators that you see A, B, C, D, they are the operators inside your Apex application. So effectively, it coexists with MapReduce. You may even have anything else running on the Hadoop cluster. As long as Yarn can give us resources within the Hadoop cluster, we are fine to run over there. Okay. So we use HDFS, of course, to store any persistent state. So it could be state of the application, it could be state of any of your intermediate variables. All that goes on to HDFS when we checkpoint. This platform enables you to scale either statically or dynamically. So static scaling is basically you say that you want to run so many instances of a particular operator and distribute the data within that. Dynamic scaling would typically be based on the changes that happen on the incoming data that you have, say volume of data. So depending on the volume of data, you could, as you see in this figure, it could auto scale 8-way, 32-way, not just a single operator, but a bunch of operators together which perform a logical operation can scale accordingly. All this data, which is processed by a single branch out of it, comes together inside what we call a unifier, which is transparently introduced by the platform the moment you start scaling. What a unifier does is it actually takes all these partial computations done by each of those branches, combines that together, and then sends it to the next operator. So it actually unifies all the data, and that's the reason it's called a unifier. So you can have parallel partitions, M-by-N partitions, all that is possible again. This is the concept of windows. So think about it coming from left. Tuples are coming from the left, going towards the right. Each window is half a second by default, as you can see. Every window has a begin window followed by a sequence of tuples which it processes, followed by an end window. Between multiple such windows, each of these is called a streaming window. And multiple of these streaming windows create what you call an application window. So the application window can be an aggregate application window, or it could be a sliding application window. In between some of these windows, some of these application windows, you could decide how frequently you want to checkpoint. So on the input side, when you get the data and when we create this input, we will introduce certain markers on the input side itself, which tell us that this is the boundary on which you can take a checkpoint, and that is again configurable. Okay, so that's and again all this checkpoint goes to HDFS from memory. So all the checkpoints are available on HDFS. Okay. So what we support out of the box, it's application state gets stored. Application master state also gets stored because that's also equally important, and we guarantee no data loss as well. We automatically recover in case of any crashes. We have had customers whom we have had to tell saying, there are some problems with your Hadoop cluster because we saw it in the logs. The application just kept on running. We have gone through the lunch test also. How many of you know what a lunch test is? Okay, so effectively it's not, I mean, it's a jargon in a way. You go for lunch and your application crashes. So what happens when you come back? How do you start the application, right? So all the data will not stop, right? So data will keep on coming in. So how do you process your data? So that's one of the tests that most of our customers have been running before they make a buy decision for us. And buffer server, as I mentioned, is one of the internal data structures. We could surely have a separate session on that. It's big enough a topic to have maybe not even one, maybe 2 sessions. So. Which processing semantics we support? So at least once, wherein windows are processed at least once. We also support at most once, wherein windows are processed at maximum once. In case of during recovery, all the downstream operators are fast forwarded to the window of the last checkpoint. We also support exactly once. In this case, of course, you have to checkpoint at every window boundary, and there is naturally, it becomes blocking because it's heavily dependent on each of the checkpoints that you are taking. So it's something that can be configured, but each one of them has its own pros and cons as well. Compute locality, again, we support rack local, which is basically you could have operators distributed across the rack on different nodes across the racks. You could have operators which are across containers but on the same node. You could have containers which are you could have operators which are within the container, which are of course on the same host, and you could also have operators which are running on the same thread. So those are the 4 types of locality from the perspective of operators that we process. You, from your business application perspective, will have to decide which one of these to use. Say, for example, you have 2 operators. One is memory intensive, other is CPU intensive. It makes perfect sense to run them within the same container because both these resources are not going to be used by any single operator. So that's an optimal utilization of your resources. So that's how you would have to decide what operator locality works perfectly for you. Yeah.
What is the technical usage for thread local?
Thread local, you want to take it?
Yeah, so in thread local, basically, you are in the same thread, and if you have too much of data that is coming in and you don't want to put it into a buffer server or consume that data, so what happens is operator 1 will process it, and that data structure is passed on to the next operator, where you have, say, file itself being copied. Tuple size is 100 MB each. That's one use case. And the other use case where basically CPU utilization is less because you are sharing the compute. And plus there are few more. We'll have one session on this.
Sure.
Definitely.
So this is the dynamic updates you could do to any operator. Properties can be changed dynamically. New operators can be added to your application. Right now, it's possible to add them only towards the boundary of the application, but there might be some other enhancements coming up. Updation of attributes is also upcoming, or I think it's done now, right? Yeah. So sorry about that. It should have been in the previous bullet. Okay, so this was the use case I was talking about from one of our customers. So what they wanted was they had a use case in the financial domain related to fraud, and they wanted to process something, and they had a limit of processing that within 16 milliseconds. Okay. So these are all the technologies that they evaluated. It's everything over there basically. It's InfoSphere Streams, Hazelcast, Spark, Ignite, Storm, Kinesis, Flink. It's everything over there, right? They evaluated each of these on these 4 points from a performance perspective, enterprise readiness perspective, roadmap perspective, and community support as well. And that's after that is what they selected Apex, and after using Apex, this is what they got. So on an average, they were able to process 70,000 records with a 600 GB RAM cluster, rather machine, I think. And the average latency that they got was 0.25 milliseconds. In fact, to tell you the truth, even we were surprised. And they have given the more details also over here. They use thread local topology. They processed 54 million events. And if you look at the thing on the right-hand side, you will see that 99.9% of the tuples, or rather 4 nines, that is 99.99% of the tuples were processed within 2 milliseconds, right? And that's the sort of performance they've achieved, and it was really mind-boggling for even us. So we surely will have another meetup wherein we could just take this use case and discuss that with you folks.
How big is the cluster?
I'm actually waiting to get that information. I mean, this information they shared today morning in the US in a meetup that they had. So I haven't got a chance to even talk to them to get that information. Today morning our time. So right, so for more information, these are the links. Surely, start contributing, be a part of Apex. It's really exciting. Lots of things to do. We'll be more than happy if you come up with any new ideas. The community has to grow as well. And it's an enterprise class product. I could surely guarantee you that. Any other questions?
So, is it possible, let's say, with lesser performance, to have exactly one semantics at a single record level? So we discussed about the windowing batching, but then is it possible for we have exactly one semantics at a single record level?
Single record level. This applies at a window boundaries basically.
Okay, so window boundaries time based, or there's also notion of window boundaries at record count based or
No,
something
this
like
is
that?
time based.
Okay, because with time based, it's not completely deterministic that it will be single record. Because
Right.
You can control how many tuples go in a single window. So you can say for 0.5 milliseconds is the length of one window. You can control how many tuples go in that window. So that allows you to, that allows you to limit the number of tuples in a window. Yeah.
The window boundaries are time based though, right? Yeah. Yeah.
From what I understood, YARN is basically used for scheduling and resource management. That's it, right? So
yeah.
Okay.
How do you install this? Because Cloudera has a Cloudera manager, because it's gonna be required.
Yeah.
So is there any specific thing that you guys do?
You want to take that? It's a bin file. You just download it and run, unzip it, and it installs. Nothing. Yeah.
Just shell script type. I mean, self-extracting installer. Absolute breeze. Nothing. I mean, nothing more than that.
See, the objective of this entire thing was to make it easy for end users to use, because what happens is operability many times happens to be an afterthought, and that is something we have done away with. In fact, that's one of the biggest things that I would say is a value add from our perspective. We have tried to make it as simple as possible to operate, not just to develop. I mean, that's also a sort of an operation, but even to operate for an end user. And if you actually look at the console, you can download the data torrent version of it also. The evaluation download is available free of cost for I think 3 months with all features enabled. So just take a look at that also. With all the rich console, it has the type of information you get out of it, and you will realize why I'm saying this. Yeah.
So it will be the single YARN application. Apex will be the single. So Apex will be the single YARN application, and all the operators will be launched in single one container.
No,
YARN containers, right?
multiple operators would come together to create a single application.
Okay.
Right? And that would be using the Apex functionality.
Okay.
So Apex platform as such is an infrastructure that will be used by your application.
Okay.
Okay?
The set of operators and the content?
Right. Every application will have its own application master.
Maybe we could talk about few more use cases, at least couple of more. Mainly if you have any specific from telecom domain.
Sure. So telecom domain, I unfortunately...
Or any other would
but
do.
yeah, I do know that Just last one. Sure. Yeah, yeah. So in the telecom domain, one of the use cases is your call data records related stuff. So when a call is made and it doesn't reach the other person, right? It could be for any reason. It could be because the person didn't pick up the phone, it didn't really make through, the tone was busy, whatever, right? So we have had the customer trying to analyze this, and they wanted to do it in the form of streaming windows. So for every of the 5-minute intervals. So that was one use case. There were huge number of records, of course. So there's another customer who's using us in the online advertising industry as well. There we are processing more than 26 billion records per day. The peak was even 36 to 37 billion records per day. We have had customers from the IoT side. We have had customers in a digital media segment wherein their processing time that they had was 15 days, which has come down to 50 minutes now. So there are different domains, different types of use cases. Because for us, we deal with structured, unstructured, whatever type of data. It typically is mostly what your business logic is that's more important. Okay. So thanks for being patient. We'll surely answer more questions. Feel free to catch either of us even during the break. And after the break, I'm pretty sure you guys will be interested. Bhupesh is going to actually write an application for you guys. So, okay. Thanks.